this is an introductory video to trigonometry. So you are going to learn about sine, cosine, and tangent ratios exist in a right angle triangle. Suppose we have one right angle triangle here. The side, the longest side, opposite to 90-degree angle is called hypotenuse. So this is the longest side and it is opposite to 90-degree. Here it's called hypotenuse. The other two legs, we call them legs or smaller sides, you can say. I am going to attribute some new names for them, either opposite or adjacent, according to one specific angle that we have chosen. Let's say according to this angle, the side that is opposite here is going to be named as opposite, and the side next to it here, next to this angle, is called adjacent side. So basically the one that is exactly the opposite is called opposite, and the next to that angle is called adjacent. So opposite, adjacent, and hypotenuse. That are the names of the sides that we are going to use in our calculations. So there are specific ratios exist in a right angle triangle. For every different angle, we will be having different ratios of sine, ratios of cosine, or ratios of tangent. But what are those? Sine ratio is known as the ratio between the opposite and the hypotenuse. So according to one angle you have chosen there, according to this angle here, the side here in the opposite direction is the opposite side over hypotenuse. So the ratio between opposite over hypotenuse is going to be giving us sine of that angle. So I mark this angle with theta here, so you can put any letter you want. Sine of that angle is going to be opposite over hypotenuse. Sine is the ratio between opposite and hypotenuse. Another ratio we have is called cosine ratio. Cosine ratio is basically, instead of the opposite sine, this time I'm going to compare the adjacent side and the hypotenuse. So basically the ratio between the adjacent and the hypotenuse, adjacent, as you remember, the side that is next to the angle that you have there. So adjacent over hypotenuse. The final ratio is known as tangent ratio. The tangent ratio is going to be opposite divided by adjacent. So according to this angle, this is the side opposite and this is the side adjacent. So opposite over adjacent. So we use one phrase called so, ka, toa to remember the initials of these sides there. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So, ka, toa, to remember all of them. There are some mnemonics. You can search through the internet if you like to learn the mnemonics as well. Let's try to figure out the sine ratio, cosine ratio, or tangent ratio of this particular angle. We have the angle here. Angle is marked with, theta here. So according to this angle, I'm going to check that this is my opposite. You can write opposite. This is next to the angle, so this side is like adjacent. And this is like our hypotenuse, because that's the longest one and it is opposite to 90 degree. So now I have identified, according to this angle, which one is opposite, which one is adjacent, and what's the hypotenuse. And then I'm gonna write my lovely phrase here. So katoa. So katoa, here sine is opposite over hypotenuse. So I can say sine of this angle is gonna be 5 over 13 because opposite is 5, hypotenuse is 13. Cosine of this angle is gonna be adjacent over hypotenuse, so 12 out of 13. And tangent of this is gonna be 5 over 12. That's the ratio between the opposite and adjacent. This is how we figure out the relevant ratios in a right angle triangle. Let's do one more example. According to this triangle, according to this angle here, I want to figure out what is the sine or cosine or tangent ratios of this particular angle. Okay, so I can just say here, sine of that angle. Remember our phrase, so ka toa. Sine is opposite over hypotenuse. So according to this angle, which one is opposite? 3. Which one is the hypotenuse? It's 5. According to that angle, let's see, we're going to find out the cosine. The one next to it, 4 out of 5. And if we are looking for the tangent ratio, tangent is basically opposite divided by adjacent, so 3 by 4. Sometimes one of the length might be missing. So according to this angle here, according to this angle here, I have the opposite, I have the adjacent, but I do not have the hypotenuse. In this case, what do we do? Remember, there is another theorem in a right angle triangle like ABC. The one that's the most famous Pythagoras theorem. So if we have two lengths given in a right angle triangle, you can actually figure out the third one by using Pythagoras theorem. So in this question, I have one side given as 5, another side is given as 7, but the hypotenuse is missing. Let's say we can mark with C, like a squared plus b squared is equal to c squared there. This allows us to find out what is the length of the hypotenuse over there. I can say c squared is going to be equal to 5 squared plus 7 squared. Okay, 5 squared is 25, 7 squared is 49, c squared is going to be 74. We know the square of c is 74. The opposite operation is going to be root of that. Square root of 74 will be the length of it. So I know now this length here is square root of 74. Then I can figure out sine, cosine, tangent, whatsoever. We write our phrase there, so katoa, all the time to remember. So sine of that angle is opposite. According to this angle, this is the opposite. What's the hypotenuse? Square root of 74. You can display this with your calculator, but this is the exact answer. If I ask you what is the sine of that angle, it could be 7 out of square root of 74. Cosine is going to be cosine theta. The side that is next to it, 5 out of square root of 74. Tangent, we actually did not need to figure out the tangent because opposite is given, adjacent is given, but I found out the hypotenuse to get these two. So tangent is going to be opposite divided by adjacent. So tangent of that angle is going to be 7/5. So this is our introduction to ratios of sine, cosine, and tangent in a right angle triangle. I hope it's clear. Thank you for watching.